Hi everyone, this is Om. Welcome back to our channel. So today I am here to discuss with you the design of two-way slab. I have already completed each and every step in design of one-way slab. So if you haven't watched that video, then you can watch that video. You can find the link in the description box, and you will also see a I button over here which is just highlighting. From there you can also go to the design of one-way slab. Now the question is, what is two-way slab? So a two-way slab is a slab in which loads are distributed in both the directions. In one-way slab, the loads are distributed in just one direction, and we provide the main reinforcement along the shorter span because the loads are divided along the shorter span. But in two-way slab, the aspect ratio is less than 2, and so the loads are distributed in both the directions, and we provide the main reinforcement in both the directions. So that was about the two-way slab. Now we need to know how can we define a one-way slab and a two-way slab. For that we have two conditions. First is the support condition. If a slab is supported on all the four sides, then it can be either one-way slab or two-way slab. So first condition is the slab should be supported on all the four sides for keeping it in a category of two-way slab. Now what is the second condition? The second condition is the aspect ratio should be less than or equal to 2. Now what is aspect ratio? So if you have watched my previous videos on design of one-way slab, then you would have known that the aspect ratio is longer span divided by shorter span. So I have already introduced you what is two-way slab, and now the question is what we are going to do today. So in today's class I will explain you the procedure of design of two-way slab. Why is this class needed? Because if you know the procedure, then you can design the two-way slab smoothly. So in the procedure I will explain you the basic points and the steps, like what to do first, what to do next, and from where we are collecting the data to do that particular step. So let's start. So our first step will be calculation of aspect ratio. So in the calculation of aspect ratio, what we see, whether longer span divided by shorter span is coming less than or equal to 2 or not. If it's coming less than or equal to 2, then it's a two-way slab, and we will go further for the design of two-way slab. Our next step will be the calculation of approximate depth from the deflection criteria. So what was the deflection criteria and what is this approximate depth? Okay, so we have a formula, L by D should be less than K1, K2, K3, K4 and multiplied by basic value. So now we get all these values from the codes. I have already explained this step in the one-way slab, or you can say design of one-way slab. You can find my link of first video in which I have explained all these terms over here. Now our third step will be the calculation of overall depth. So once we get the approximate depth from the step 2, then in step 3 we can use that for the calculation of the overall depth. Our fourth step will be the calculation of effective span. the least value of first clear span plus effective depth, and second center to center distance between the supports. From these two values, whichever is less will be your effective span. I have already explained all these things in the one-way slab, and I will also explain all these things in the upcoming classes when I will go for the design of two-way slab. So our next step will be the calculation of load. One more important thing, I will choose the slab from the structure that we have already designed in Slab Pro, and you can find the link of that structure design in Slab Pro over here. So after that, now you know from where I am getting the data. So I will take a two-way slab from our already existing design, and then we will calculate the load over that. So while designing in Slab Pro, I have taken dead load as 2 kN per meter square and live load as, we have taken dead load as 2.5 kN per meter square and live load as 2 kN per meter square. So we will use that data to calculate the load on the slab. Then in step 7, we will calculate the bending moment. So to calculate the bending moment, we need to know the value of alpha x negative, alpha x positive, alpha y negative, or alpha y positive. So we will know all these values from the table 26 of IS 456. From there, we will calculate the moment. Moment will be mu is equal to, like mu x positive will be equal to alpha x positive into WL square, where W is the factored load. Once we calculate the dead load and the live load, we will add that load and then we will calculate the factored load. That total factored load will be the W, and the term L will be the shorter effective span. Then once the calculation of moment is completed, then we will go for the calculation of the AST, like how much quantity of steel is required in your design. So after you know what is the AST required, then you can calculate the main reinforcement. So we will first calculate the main reinforcement along the shorter span, then we will calculate the main reinforcement along the longer span, and we will also decide how much spacing we have to provide along the shorter and the longer span. Then we will make a drawing of the design, and hence our design of two-way slab will be completed. So in total you have to calculate, or you have to go through almost 8 steps, which is very simple, and see you in the next class. Till then, take care. Bye bye.